Hey guys, I'm about to go over the study guide with you for Unit 12. This is the study guide that I gave you yesterday, which is Monday. And I'm not here today, so I wanted to walk you through the study guide. Hopefully that will help you prepare for the test, which is tomorrow, Wednesday, okay? So hopefully you have your study guide out. Let's look at number 1. Cora adds 2.37 grams of baking soda to her chemistry experiment. How many milligrams of baking soda does Cora add? I need to find my little sheet. So here's this reference sheet, which hopefully you have. Pasted, glued into your composition book. Let's hope by now. So that's going to help us, right? So Cora adds 2.37 grams. So I like to get an idea what's going on here. 2.37 grams. How many milligrams does she add? So this is just a simple conversion problem, right? So I need to know grams to milligrams, right? Again, make those T-charts. Don't just do it in your head. And so I can use this to help me, right? 1 gram equals how many milligrams? Well, it's right there, 1,000. 1 gram equals 1,000 milligrams. So that sometimes it's nice to do 2 and 3 and 4, but in this case, since it's decimals, that won't help you a lot. What I recommend is you figure out what's going on here, right? 1, what is happening to 1 to make it 1,000? 1 times what makes 1,000? So times 1,000, right? 1 times 1,000 makes 1,000. So that means 2.37 times 1,000 will give you your milligrams over here, okay? Again, when you're doing multiples metric system, when you're doing times 10, times 100, times 1,000, you can move that decimal point to show that you're moving by a power of 10, right? So if I have 2.37 times 1,000, I can start at the decimal and go 1, 2, 3. So now I've already passed what will be the ones place, so I need to put a 0 there. Otherwise, it's not going to make sense. So I go over here, 2,370. Right, that's a comma now, not a decimal. So your answer there should be A. And again, if all you're writing on your paper is A, then you're really not helping yourself at all. Make sure that you write all this, show all this work that you did to get it, okay? Number 2, which measures are equivalent to 10 quarts? Choose all that apply. So that might take you a little bit, right? So I'm going to put up here, I'm going to say 10 quarts equals what? Right, just to get me started. So I know that quarts, so I know, I'm trying to think the best way to show you this because some of these could actually get bigger, and we don't want to get bigger. We want to go from big to small on all of this. So we've got A, 160 cups, B, 80 pints, C, 40 cups, D, 20 pints, E, 2.5 gallons, F, 320 fluid ounces. I'm trying to think if there's any I could just automatically mark off. I'm going to look up here and say quarts. And what I see, like pints are bigger than quarts, right? I'm sorry, gallons are bigger than quarts. Liters, well, that's a whole different thing. So let's see, what's the easiest thing to do here? I guess I would say the first thing I can do is pretty simple to do quarts to pints because that's right there on the sheet. 1 quart equals 2 pints. So whatever I have is times 2. 1 times 2 is 2. So that means times 2 is what's happening here. So let's see, we have 10 quarts. So how many pints would we have? 20 pints, right? So that means D is correct. Also means any other pints are wrong. So B would be wrong. Okay? Does that make sense? Because we figured out that 10 quarts equals 20 pints. So it can't also equal 80 pints. That doesn't make sense. So then let's see, we've got 20 pints. Let's go to cups because we can go from pints to cups. right? 1 pint equals 2 cups. So again, it's another times 2 type situation. So right now we have 20 pints. We figured out that 10 quarts equals 20 pints. So let's figure out what 20 pints equals in cups would be 40, right? So that would be C. That means I could also cross out what? A, right? They can't have two different answers for cups to equal the same thing. So I don't have to calculate every single thing on this question. I just need to do enough to answer the question. So now I know that C, 40 cups, D, 20 pints is right. I need to figure out E and F. So let's see, cups to fluid ounces. We can do that, because again, that's up on our little sheet here. So we can do cups to fluid ounces. 1 cup equals 8 fluid ounces. Again, I'm just getting all this information at the top of these. I'm just getting off my sheet here. So let's see. We are up to 40 cups. And so we need to know how many fluid ounces. So really, this is 1 becomes 8. So it must be times 8. So I'm going to have to do 40 times 8. I know I can do 4 times 8 is 32. So 40 times 8 has to be 320. So 320 cups, 10 quarts is 320 cups. That's there too. I'm sorry, fluid ounces. Sorry. So 320 fluid ounces. So F is correct. 2.5 gallons. If you have 10 quarts, this is where you'd have to go the opposite direction. And we're not really supposed to have to do that. But let's take a look and just make sure that E doesn't happen to be right. So let's see, we can say gallons to quarts, right? We know we have 10 quarts. I'm sorry. It's the end of the day here. So let's see, 1 gallon, I look up here, equals 4 quarts. So that means if I have 10 quarts, yeah, see, this isn't really, I don't think we're going to do this to you on the real test. But let's see, so this is times 4. Let's see, would 2.5 times 4 make 10? 25, 50, 75, 100, so 2.5, 5.0, 7.5, 10. It would actually. So that actually would be right as well. So you'd have C, D, E, and F are all correct. That's a tough one. Kind of a tough one to have on number 2. Sorry about that. But I don't make the tests. So on that, do the best you can to figure them out. And if one goes the other direction, you can use that little trick I showed you. I don't think we're going to do that to you on the real test. I hope not. I got to go a little faster here. It's going to take me all night. Now, we did some of these together today, so I'm not going to do those except just to remind you what the answers are, because we went over them today. Number 3, James worked on a puzzle for 1 3/4 hours. For how many minutes did James work on the puzzle? Okay, so I like to get something written here. 1 3/4 hours equals how many minutes? So there's different ways we could do this. Again, a T-chart is always pretty nice. If I go from hours to minutes, I know that 1 hour is how many minutes? 60 minutes. So I could kind of go down here and say 2 hours would be what? 6 times 2 is 12, so 60 times 2 is 120. And in here somewhere is going to be our answer, right? So again, there's different ways we could do this. If we could think like, what's 3/4 of an hour? That might be a nice way. Like I could think, 15 minutes is 1/4 of an hour. 30 minutes is half an hour. 45 minutes is 3/4 of an hour. So what we're really talking about up here is 1 hour and 45 minutes. So I could just say 60 plus the 45 minutes I just figured out. That's one way we could do it. There's lots of different ways I think that you could approach this. The main thing is figuring out what 3/4 of an hour is, I think is going to be your trick. You could do 3/4 of 60, right? Because that's really what we're trying to figure out. So 3/4 times 60. 3 times 6, 180 divided by 4, right? That will get you your answer. So you could also do, yeah, I think that I wouldn't go any farther than that. So what you need to do is figure out some way to convert these hours into minutes, knowing that 1 hour is 60 minutes. Anything else you have to figure out along the way, right? You could think that, oh, what's half an hour? That's 30 minutes, right? You could do whatever you have to do to using what you know, which is that 1 hour is 60 minutes. From there, you can use a T-chart. You could even draw a picture of a clock and count some things out. There's lots of ways you could approach it. Number 4, a frog jumped a distance of 3.12 meters. How many centimeters? Okay, that's not bad, right? Meters, 2 centimeters. I'm going to look at my chart. 1 meter equals how many centimeters? 100. So that means really what we're doing here is times 100. So 3.12 times 100, you're going to go 1, 2, 312, right? Powers of 10. Moving the decimal once, that's times 10. Moving it again, that's another times 10. That's why the metric system is so simple. So your answer there should be A, 312 centimeters. Number 5. Jennifer goes for a walk that is 5/6 of a mile long. How many feet did she walk? So we need to know what a mile is. We know she walked 5/6 of a mile. So we can do 5/6 times whatever a mile is, but we don't know what that is right now. So let's take a look at our little chart. 1 mile equals 5,280 feet. So we're going to do 5/6 of 5,280 feet, okay? So that's a tough one. I mean, that's one where you're going to have to actually work it out in order to figure out, trying to think if there's a quicker way. I don't see a really fast way here. So I think you're going to have to do 5 times 5,280, and then you have to do divided by 6, right? Because this of means times. So let's go over here. Let's try it. If you think of a quicker way, let me know. But I'm going to do 5,280 times 5. So you could write 5,280 plus 5,280 plus 5,000. You could write that 5 times and add it if you're not sure how to multiply this. Hopefully you can multiply this. 5 times 0 is 0. 5 times 8 is 40. 2 times 5 is 10. Plus 4 is 14. 5 times 5 is 25, plus 1 is 26. So 26,400 divided by 6. Yeah, I don't really love this way of doing it. Offhand, I don't see an easier way. If somebody thinks of an easier way, let us know. Because 26,400 divided by 6 is going to involve some thinking, right? Let's get a different whiteboard here. 26,400 divided by 6. So again, I like to come over here and say, well, let's see, what if I did 6 times 10, 60? That's not even close. How about 6 times 100? 600. That's still not really very close. 6 times 1,000? 6,000. That's getting there. If we did 6 times 10,000, we would get 60,000, so that's too big. So we could do this times 6. Times 1,000. Yeah, I don't love this for a method that you guys are actually gonna be able to do. All right, well, let's go with it for now. Maybe we'll think of a better way. Okay, so I take away that 6,000 from what's already here. End up with 20,400. Yeah, I guess a better way. I mean, you could just keep taking 6,000s away. Because we could do another 1,000. I'm thinking just because we haven't done any that are this big, I don't know that this is going to be that helpful to you. Let's see. We could do another 1,000. Just, you know, our partial quotients. We can do this whenever we need to. And we've done this quite a bit. So now we're getting down pretty close. 8,400 times another 1,000. Okay, now we're getting there. So I can say I've done 4,000 so far. I could also do 6 into 2,400, which that's getting where I can actually kind of realize what that would be. Because I know 6 into 24, right, is 4. And then so there's 2 more zeros after that. So I think you're going to have 4,400 feet. And that's answer C. I'm going to think about this one. I may show you a different strategy when I come back on test day, because I'm feeling like surely this isn't the best way to do this. I mean, you have to at least know 1/6. Yeah, I don't love that question. Okay, moving on. I'll let you know if I find a better way. But because miles are so annoying, 5,280 feet, there's not, a lot of times there's not a simple way to solve it. Number 6, Frank has a board that is 2 meters long. We've actually kind of looked at this before. He cuts off a piece 72 centimeters long for a shelf. These are where I would draw a picture, right? Number 6, Frank has a board that's 2 meters long. So I'm going to say 2 meters. And I know we went over this one. He cuts off a piece 72 centimeters long. I don't know how long that is. I mean, I can't see it on here. How many centimeters does he have left? So we need to figure out where he cuts and then what would be left. So I need to go meters to centimeters, because I need to be able to look at this in centimeters. So he had 1 meter is 100 centimeters, you know, from my chart. 2 meters is 200 centimeters. So that 2 meters is the same as 200 centimeters. And then I need to take away 72 centimeters from my problem, right? 200, take away 72 centimeters. Okay, so yeah, this is where you have to kind of do your regrouping, unless you want, you know, there are ways to kind of count forward. Like you could think, well, 72, how far would it be to get to the next 10? And then how far would it be to the next 100? So I could say 72, plus 8 is 10. You know, and then I'm up to 80. So then plus 20 is 100. And then I'm up to 100 plus 100 is 200. So I could do it that way. You know, that's one way to get there. But I think most of you know how to do this regrouping. So do what you know. But 128 centimeters is what we get. That is one of the answers. And so that should be good. He cuts off 72. Yeah. 128 centimeters C. Again, use your common sense here. If this is all centimeters and you're cutting off 72, how much do you have left? It's not going to be 1 or 12 or almost 2,000. So none of those answers even really make sense if you really picture the problem. Number 7, I think we talked about distance around a field, right? It's 600 yards. I like to draw my little person. I'm going to go fast because I think we've done this. So every time that person goes around, that's 600 yards. Then Yolanda goes around again. That's another 600. And then again, that's another 600. And then she goes halfway and stops here. So we know halfway would be 600. Okay? So we add all those up. We get, 1,800 plus 300. Or, there's different ways you could figure this out. 2,100. Okay? That's one of the answers. We must be done. No. It asks how many feet, okay? So I have to think up here, feet, from yards to feet, right? I know that 1 yard is 3 feet. So that means that 2,100 yards, we have to do times 3, 2,100 yards. If you do the math, you can think about it. 2 times 2 is 4. We need to do times 3. 2 times 3 is 6. 1 times 3 is 3, and then 2 zeros. Should end up with 6,300 feet. Again, we've done this. That's why I'm going so fast. We did these today, 8 and 9. Ian measures the length of tree cones. If you remember how many tree cones are represented, you count all the X's, and it should be 19 X's. Which measurement occurs most often? Just which one has the most X's, right? 6 and 7/8. Remember that when you get a problem like this, you want to think about what are the X's, what do they represent? In this case, cones that fell off the tree that he found. What do these numbers down here represent? These are the lengths of the tree cones, right? If you don't know that, it's hard to answer. And then Dante measures the water. So again, we talked about this, the difference between the greatest and the least. You do 3/4 minus 1/4. Because it says just one jug. Each X is a jug. So you're just talking about one jug. So 3/4 minus 1/4, 2/4 or 1/2. How many gallons are there in all? We did all this. We have to add all these up somehow. We tried to make one as often as we could, right? Like 2/2 is 1. 3/4 and 1/4 is another 1 whole. I believe we got 4 gallons of water, 5 gallons? I think it was 5 gallons of water when we did it all out. And then down here, creating a line plot. Just remember, you're gonna make yourself a number line and be sure you put equally spaced things. On this number line, we just end up saying 1/4, 2/4, 3/4, 4/4, or 1 whole, 1 and 1/4. And that's all the data there is. If it helps you, you could put a 0 down here, but you don't really need to. And then we just look, there's a 3/4, there's another 3/4, there's a 1/4, there's a 1 and 1/4. Oops, that's here. There's a 3/4. There's another 1/4. There's a 1, and there's a 3/4. So we should end up with a line plot that looks like that. Okay. 11. I believe I did this with one class, but I don't think I got it with both. But basically, you have Rachel, Sally, and Tracy measuring their heights, and their heights are shown from shortest to tallest. What's the order? What I would do is get everything down to millimeters, because you know how to go from big to small. You don't always know how to go from small to big, okay? So I would say Tracy's height is in meters. So we could do meters to centimeters. 1 meter is 100 centimeters. So that means 1.4 meters, right? This is times 100. We move our decimal 2 times. So we get 140 centimeters, which makes sense. You know, look back into, if 1 is 100, 1.4 is 140. That makes sense. Okay, but we're still not to millimeters, so that's where we can do centimeters to millimeters. And that is 1 to, we're going to look back at our thing. That is 1 to 10, right? Because meters to millimeters, that's where you get 1,000, but from 1 to 10. So again, if you've got 140 centimeters, you're just going to do times 10 and get 1,400 millimeters. And then the only other one is Sally is 163 centimeters. So again, we just do centimeters to millimeters again for Sally. So that's 1 to 10. Sally is 163 of these, so she would be 1,630, because that's going to be a times 10 one. Again, I'm sorry, I'm going fast, but we've talked through a lot of this. So you end up comparing 1,400 to 1,630 to, and Rachel's was already in 1,760. So you should have Tracy first, then Sally, Tracy, Sally, and then Rachel. And then number 12, talking about a paint bucket. This is just a simple conversion problem, but we got to figure it all out, right? It's pretty simple if you understand how to do conversion. So if a paint bucket, and again, this is where I told you, like, you can draw a paint bucket, get your practice drawing cylinders, all right? And it has 5 gallons of paint. Okay. After Amelia paints her dresser, there are 64 cups left. How many does she use? So we need to do 5 gallons, take away 64 cups. Okay. That's the problem we have to do, but that's not quite that simple because we don't know gallons to cups. Now you might by now, but you also might not. So let's say a gallon, let's go gallons to quarts. I'm just looking at my little sheet here and I'm following it, right? 1 gallon equals 4 quarts. That's easy enough. 1 gallon equals 4 quarts. So that's a 1 times 4 is 4. That's the times 4. If I have 5 gallons times 4, that's 20. So now I'm up to 20 quarts. So I'm thinking all along the way, I'm understanding this, right? That means 5 gallons, what's in that bucket is the same as 20 quarts. Same thing. But I need to get to cups, so I'm not done. So let's go quarts. Look back at my sheet. 1 quart is 2 pints. Let's go quarts to pints. 1 to 2. So that means this is a times 2 situation. What do I have so far? I've got 20 quarts times 2. I've got 40 pints. Right? So that means inside that bucket, there's 5 gallons. We can also call it 20 quarts. We can also call it 40 pints. It's all the same thing. It's just different ways of measuring it. We're still not done though, because we have pints, but we still don't have cups. So let's look back here. 1 pint is 2 cups. Okay, I can do that. 1 pint, 2 cups. 1 pint is 2 cups. That means it's a times 2 kind of situation. So 40 pints, 80 cups. Okay, so now I know that 5 gallons is the same as 80 cups. So now I can take away what Amelia did. She did 80, she started with 5 gallons, which is 80 cups, take away 64 cups. And she ends up with 16. I'm sorry, after she painted her dresser, there were 64 cups. Okay, so we took away the 64 cups. How many did she use to paint her dresser? 16. Okay, because that's what we were trying to figure out. We know she started with 5 gallons and she still had 64 cups left. So that's why we took away the 64 cups and we ended up with 16 cups. Okay, so that is the whole test, the whole study guide. And you can also watch this video tonight. I will send it home and hopefully that will help you get ready for the test. Good luck.